Welcome to this video on correlation and causation. By the end of this video, you should be able to define correlation and causation and explain the differences between them, determine if a situation described as correlation or causation, use 4 traits to describe correlation, and use Desmos to find correlation. Alright, so what is correlation? Correlation is a statistical way to measure the relationship between two sets of data. So we're just looking for a relationship. Causation indicates the relationship between the two events where one event is actually causing the other event. You can have data that is correlated, but that does not mean one causes the other. So correlation does not indicate causation. So let's take a look at an example here. There is correlation, meaning a relationship between the number of firemen fighting a fire and the size of the fire. But the presence of more firemen does not cause the fire to become bigger. Okay, so that's just a correlation. If a whole bunch of extra firemen showed up, that didn't mean the fire would go, oh, I need to become bigger now. Okay, it's just a correlation. So let's try a couple of examples and see how we do. So a recent study showed that college students were more likely to vote than their peers who are not in school. So is being in college causing the people to vote? That means if you're in college, you have to vote. And if you're not in college, you're not. It doesn't cause it, but it is correlated. Okay, let's try it again. Dr. Henderson noticed that there was more trash in the hallway after second period than after first period. Just because it's after second period didn't make it be more trash. Okay, because there could be no trash after second period. So the time doesn't cause the trash to appear. So this is a correlation. And our last one. You hit your little sister and she cries. That would be a causation. You hit her and she cried. So when we go to describe correlation, there's a number that we can use called the correlation coefficient. And we're going to use the variable r for the correlation coefficient. The correlation coefficient is a number that is always, always, always between -1 and +1. You cannot have any other value, anywhere from -1 to +1. And there is 4 traits that we look at to help us describe correlation. They are the form, meaning what is the shape, okay, we look at the direction, and we're looking for positive or negative. We're looking for the strength, and that has to do with the size of the number, the correlation number, and any outliers. Okay, so we're going to use these to describe the scatter plots, which is a two-way it shows the relationship between the two variables, and that helps us understand our correlation. Now, the tighter the grouping is of the dots and the more along a particular line that they follow, the stronger the correlation. The more scattered out that these dots are in the scatter plot, the weaker the correlation. So I like to kind of envision a line going through the middle of the data. And you can see how a lot of this data is really close to that line. Okay, but that's very clearly a line because we're talking form, and form is shape. So this would be a linear relationship here. And we can only get correlation on a linear relationship. But there's other shapes that you could see. This shape, I'm going to draw a curve right through the center of it, or as close as I can get. This shape is actually a quadratic. This is a parabola. So this would be considered quadratic. This shape here, if I bring a curve right through the middle of it, this one we just studied, this is an exponential. And this one has no shape. You cannot see anything that's going on here, so we wouldn't be able to give it a shape at all. All right, let's talk about direction. So with direction, you're just looking, does your correlation is going to be positive or negative as you read from left to right, because we're going to read our graph from left to right. So we can see if we draw a line through the middle of our data, you can see that line would have a negative slope. So this would be a negative correlation. And one thing to think about when we're looking at this, as our x values get bigger, our y values are getting smaller. They have an opposite relationship that makes it negative. We could also say that conversely, as x's get smaller, the y's get bigger. When they have an opposite relationship, your correlation is going to be negative. And we can look at this one. I'm going to draw a line kind of right through the middle of it, and I can see that line would have a positive slope. So this would be a positive correlation. Okay? And when your x values get bigger, your y values get bigger. When your x values get smaller, your y values get smaller. The direction is the same. That will make it a positive correlation. Now with strength, remember I said our correlation is always going to be between -1 to +1. Okay? So the negative sign refers to which direction is the line going, like we talked about here with direction. And the strength is how close to a straight line are we talking about. So let's look. See how tightly those are grouped to the line that I drew through them. That's going to be a really strong correlation, and it's sloping down, so it's negative. So it's going to be a negative number. So I'm going to give you just kind of a number, maybe -0.9. Not quite all the way to -1. -1 would be the very strongest number we could get. All the way over here, if I draw a straight line right through the middle, you can see that's pretty tightly grouped. This has got a positive slope, so this could maybe be a positive 0.9. Okay, the strongest it could possibly be is a positive 1. In the middle, if you get a scattering and you really can't tell what's going on, that's going to be a number close to 0. Okay, and then we have some here, so you can see how they kind of scatter out a little bit more. I'm going to draw that line. You can see how these points are further away from that line than these points were. So this is a weaker correlation, so maybe this is like a 0.75. Same over here. If I draw my line through the middle, they're more scattered out than this was, so it's a weaker correlation than this one. So we're kind of estimating here, because our eyes are actually very bad at estimating correlation. We do better when we calculate it, and we're going to do that shortly. Okay. So the important takeaway here is the closer they would be grouped to a line drawn through the middle of them, the stronger the correlation, and the sign just determines whether it's a positive, negative slope or a positive slope. And finally, outliers. We want to pay attention if there's a data point that falls outside the pattern of the rest. Okay, so we could have that, or we could have even had a point that fell all the way out there. That is still an outlier, because it's way far away. It's away from this cluster of data here. Okay, so when we're talking about correlation, strongest is the closest to 1, positive or negative. The negative doesn't mean it's smaller than a negative 1 is not smaller than a positive 1. It's just as strong. It just has a negative slope instead of a positive slope, because remember the strength is talking about how close they would group to the line that's drawn through them. Okay, so the negative signs and the positive signs don't matter. It's the actual number that matters when we're talking about strength. So if we're going to put these in order from the strongest to the weakest, the very strongest in this set, the thing closest to 1 is going to be the strongest. In this case, -0.98 is our first number. That's the strongest of these correlations. Okay, so we want the next biggest number, which is a positive 0.87. It doesn't matter that it's positive, it's how close would the points group to a line that's drawn through them. Okay, then our next biggest number would be -0.81, then 0.43, and our very weakest one is 0.07, because remember, the closer to 0 you are, the more scattered out they are. All right, let's try that again. The very strongest, it doesn't matter about the negative signs, it's just the number closest to 1. is going to be the strongest, positive or negative 1. So negative 0.65. All right. Our next biggest number is positive 0.63. Then we have negative 0.42, positive 3.2, and 0.04. Strongest to weakest. The closer to 0 you are, the weaker you are. So we're going to try that by looking at a scatter plot, not just the numbers. So we can see we got some that are really scattered out. That should be pretty close to 0. If I draw a line through here, I can see there's quite a bit of scattering from that line. I'm going to draw a line in here. Those are fairly grouped tight with a negative slope. Draw a line through here, and those are fairly grouped tight but with a positive slope. So let's take a look at these. All right, so the closer you are to positive or negative 1, the closer to a line you are. So if we look at these, those are pretty close to the line. And of our choices here, the best choice for this one would be negative 1. It's pretty tightly close. 0.5 is going to be a lot more scattered out. Okay, we also have a positive one. Notice we have a positive slope right here, so I'm going to say that's a positive 1. This is so scattered you can't even tell where to draw a line. There's like no correlation going on at all. So of our choices, that's going to be our best, 0. Now this guy, you can see he's pretty scattered out. He's not tightly grouped around the line. So we don't have a lot of choices because it's not as tight grouped as it would be for 1s, and we already used a 0, so it'd have to be one of these 0.5s. Well, this has a positive slope on this line, so it's going to be positive 0.5 for that. All right, so let's try if we can name some correlations from some scenarios. All right, so reading these scenarios, think about what the x value is doing and what the y value is doing. You don't really have to worry about which one's x and which one's y. Just are they moving in the same direction or in opposite directions? Remember, if they're going in the same direction, they're positive. If they're going in opposite directions, they are negatively correlated. So the number of hours you work, so let's think about it, versus the amount of money in your bank account. So the more I work, the more money is in my bank account. Those are both going in the same direction. That makes this a positive correlation. Okay. Now, how about the number of hours a worker receives safety training versus the number of accidents on the job? I would expect if we get more safety training that there's going to be less accidents. Those are going in opposite directions, so this is going to be a negative correlation. Even though the overall topic is positive, less accidents is great, but the correlation, the relationship between more safety training and the number of accidents is going to be negative. How about the number of students at Etowah versus the number of dogs in Atlanta? I don't even know where to start with that. Like, okay, there's more students at Etowah. What does that mean about the dogs in Atlanta? I'm going to have to go with this is no correlation. I can't see a relationship there. Right. But the number of heaters sold versus the months in order from February to January. So, no, sorry, February to July. So we're counting up the months, February to July. What's going to happen to the number of heaters sold as it goes from colder to warmer months? The number of heaters sold should decrease. So that would make this have a negative correlation. About the number of rice dishes eaten and the number of cars on I-75 throughout the day. I mean, there's nothing I can see that even makes me think of a relationship, so I'm going to call this no correlation. And finally, the number of calories burned versus the amount of exercise. Okay, well, think about it. The more you exercise, what happens to the number of calories burned? It's also going to increase. They're both positive, so this is going to be a positive correlation. All right, you need to pause the video at this point and open up Desmos so you can follow along with me. All right, so you need to keep these instructions in front of you to follow along. I'm going to pull the Desmos screen over so I'm going to speak them out loud so you can follow along on your paper. So the first step is to click the plus button at the top left side of the screen. So that's right up here, the plus button. Click it. And then choose the table icon. All right. We're going to enter the data values in the X and Y columns. The values must remain paired together, and you cannot split an X value from its Y value. All right, so what we're going to do is we're going to try this first table down here. So we're entering the data points. So when you enter 1, the 2 has to go in the Y column. When you have 2, the 5, and the X, the 5 has to go in the Y. They have to stay paired up like they are on the paper. So let's see what that's going to look like. So we have, I usually put all the X's in and then go back and put the Y's in. 2, 3, 4. And then I got to go all the way back up to the top, and I have a Y value of 2, 5, 8, and 12. All right. Now, the next step says, click below the table to start a new line. So right down here, click to start your new line. And you're going to type Y1, and it will say this 4-element list because that's what it's referring back to this. Now the next one, you're going to push the Shift key and the top left button next to the 1 key. This is called the tilde. So Shift and the button to the left of the number 1, and you should get this squiggly line. It's called the tilde. Okay. Then we're going to type MX1 plus B. So when I do that, it should pop up all this information for you. There's a lot of stuff here, but all we're concerned about is correlation. And remember, correlation uses the variable R. So right here it says R equals. We don't need R squared. We're only talking about R. So R equals 0.9973. So the correlation of this table is 0.9973. So this is very strong because it's pretty close to 1, and it's positive because that's a positive number. So we're going to try it again. We're going to follow all of those directions, and we're going to input the table of the second, the data from the second table in. So I'm going to close that, close this. I'm going to hit plus, choose the table. I'm going to put in my X values. Remember, you can pause the video at any time to catch up. So we got 10, 15, 20, 25, and I'm going to plug in my Y values, make sure they line up. I have to have the 37 next to the 10 because that's how it is on the paper. Okay. You're going to click the line below, and you are going to type Y1, your tilde, which is Shift the key to the left of the 1, so it gives you the squiggly line. And then you're going to type in MX1 plus B, and it should give you all this information again. And this time, here's our correlation, negative 0.9882. That means negative 0.9882. That's strong. That's really close to negative 1, so we're going to call that strong. And it's negative. And the other thing we always want to say, you really cannot get a correlation coefficient unless something's linear. So we're just going to add the word linear to these two. We can identify the other shapes by graphs, but you should never get a correlation coefficient on something other than a line. So this would be strong positive and linear. This would be strong negative and linear. We're going to try one last one. Notice this table goes sideways. These are the same. It's just whether they're vertical or horizontal. It doesn't really matter. And pause the video, put your data in, and see how you do. Okay, so when I have my data in there, I see I have a correlation. It's negative, but that number is much closer to 0 than it is to 1. So when I put this on my paper, let me double check what that was again. It was a negative 0.2482. So negative 0.2482. We're going to call this a week. negative linear. All right, hopefully that was helpful. Remember, you can go back and review a video anytime you need to. See you in class.